Hi friends, today in this session I will talk about the classification of dyes and it is a topic in our mold and dye design subject for B.Tech Polymer Engineering students in our Crescent University. So I am myself Dr. Behera from the Department of Polymer Engineering School of Mechanical Sciences at B.S. Abdur Rahman Crescent Institute of Science and Technology, Chennai. So the topic is classification of dyes. And the function of a die is to create the plastic parts, like in case of injection molding, actually is to use a mold to make the part. So here also the melt will come from the extruder and it will go through the die and finally actually will get the plastic product. The difference between actually in case of injection molding and in case of extrusion, they are actually used to get actually the plastic products, but the operation is actually intermittent type. Here it will be a continuous type of getting plastic products. So to make the plastic product, you have to construct the dies, you have to design the dies. So before going for actually design of the dies, we should know what are the different type of dies. What are the different type of dies used in case of actually making plastic products. So the dyes are classified by three ways. The extrusion dyes are classified by three ways. Number one, it is according to the type of extruded. So extruded meaning is actually the plastic product what you are getting. So like sometime actually used to get actually product of hollow shape and sometimes used to get actually solid shape. So accordingly actually we used to classify the dyes according to the type of extruded. Then we can classify the dyes according to the direction of flow of melt, because the melt will come from the extruder and that will enter the dye. So how it is entering, according to that actually you can classify. That is according to the direction of flow of melt. And third way of classifying dyes according to the type of construction of the dye. How you are going to manufacture the dye, we can classify according to that. So number one, according to the type of extruded, that is the plastic product. And number two is according to the direction of flow of melt, how the melt is coming from the extruder and it will enter the dye in which direction. So based on that one, we can classify. And few of the plastic products actually they are manufactured uh, in and available in market, and we'll go for some examples. And the third way is according to the type of construction of the dies. So repeating again, classification of dies can be made actually by three ways. One is according to the type of extruded. Second one is according to the direction of flow of melt. And the third one is according to the type of construction of the dies. So let us go one by one. The first one is according to the type of extruded. According to the type of extruded, there are two types. There are two type of dies. One is actually solid extruded dies, and the second one is actually hollow extruded die. Solid extruded die and hollow extruded die, that is based on actually the type of product how you are getting, whether the final product or the exit of the die when the product will come out, whether its shape is actually a solid one or a hollow one. Based on that one actually it is classified. So according to the type of extruded, two types: solid extruded die and a hollow extruded die. So in case of solid extruded die, they are used to manufacture plastic components like plastic rod, plastic sheet, or these profile dies, like actually you are making actually the plastic PVC, UPVC type of components which are used actually in our different buildings. For example, actually I'll say is one is actually to make window, the other one is actually to doors. So those type of plastic components, when you are going to manufacture, the type of die will be used, actually it will be a solid die, solid extruded die. Then there are products which are actually look wise, they are hollow in nature. For example, actually this PVC pipe will be the best example. So hollow extruded dies are used to manufacture hollow parts, like actually as I told already, these are pipes, or in case of actually wire coating components, because we used to put actually polymer component, sorry, polymer uh, cover on the outer surface of actually these electrical wires. So they comes under the actually wire and cable coating type of extrusion. So three types, classification three type. One is based on the type of extruded. Second one is actually based on the type of direction of flow. Third one is actually how you are making it. So according to the first classification, again actually the dies are actually two types. One is solid extruded die. The second one is hollow extruded die. And for different type of products, plastic products, to make actually extrusion, and how the die look, and again actually we'll go for different classification that will be in future. And the second one is according to the type of second classification, according to the type of direction of flow of melt. So based on the direction of flow of melt, the dies are classified in three ways. Like in case of extruded, two types, solid and hollow. Here actually, based on the direction of flow of melt, they are classified actually three ways. Number one, straight through or inline die. Repeating again, that is called inline die, very easy to remember, or that is also called straight through. That means that type of die is what will happen. The material will come from the extruder and directly enter the die in the same line. That means suppose it is coming actually along the horizontal direction. Again that one will enter actually along the same axis. That one also. That means the axis of your extruder machine and the axis of this die, both will be actually single line. Axis will be same. So that type of dies, to make some type of products actually used to use that type of dies, they comes under the category of inline die. The second one is cross head die, and third one is offset die. So according to the direction of flow of melt, the dies are classified again three types. One is inline die, second one is cross head die, and third one is offset die. So as I told you already, actually what used to happen in case of inline die, in case of inline die, the plastic melt in the extruder flow in the same line, in the same direction with the extruder. That means the axis of extruder and the axis of the die, both are actually lies on the same axis. So it will come from the extruder and it will enter the die. And generally they used to keep it horizontally. So that comes under actually inline die. Second one is cross head die. What is to happen in cross head die? The melt will come from the extruder. Suppose assume that that is actually x-axis. Then it will flow along y-axis. That means it will make 90-degree angle. The melt flow will be diverted from its original direction by 90 degrees. So in case of cross-head dies, the flow of melt is diverted perpendicular to the axis of extruder. It may be upward or it may be downward, or in some cases it will be sideways. But the direction actually deviation from the original axis of flow, it will take at 90 degrees. So if it is upward, in some cases, in practically actually this blown film dies, they are actually comes under the category of actually where the melt will flow horizontally, after that it will go upward. The other one is actually downward direction flow, that is actually called cast film or Parisian die, or in some cases the flow will be 90 degree, but the melt will from the original direction it will flow at 90 degree along sidewise. So which is example of actually your AR and cable coating dies. So okay, so in case of inline dies, the melt direction will not change actually. That means the direction in which it is coming from the extruder, the melt will enter the die in the same direction. But in case of cross-head die, the melt will come from the extruder. Assume that it is x-axis, but again it will flow actually at 90 degrees, that is along y-axis. But triple chances are there, it may flow upward, it may flow downward, or it may flow sidewise at 90 degrees. So as I told, actually when we will go for our future classes, as my future videos, where actually we'll go for individual type of dies. So when we'll go for blown film dies, the blown film dies comes under actually this category. That means comes under crosshead die, where to make actually this bigger size plastic cover and all, we have to go for actually blown film process, blown film extrusion process, and the type of die we will use there, that is called actually blown film die. The third one is offset die. In case of offset die, what will happen is again variation compared to your first one and second one. In case of first one, the melt flows along the axis of the extruder. It will enter the die, the direction in which it is coming from the extruder, along the same direction it will enter the die. But in case of cross-head die, the melt will come from the extruder in one axis, then it will make actually 90 degrees before it will enter the die. And some of the dies actually, some of the plastic products used to manufacture by that way. The third one is actually offset die. Offset die, what will happen? There is a little variation compared to cross-head die. In case of cross-head die, the melt will be diverted perpendicular only once, but in case of in case of offset die, the melt will be diverted 2 times. So in offset dies, the melt from the extruder is diverted 2 times at right angles and is maintained offset to the axis of the extruder. That means there will be some distance. There will be some distance. Suppose finally actually it is coming along x-axis. The melt is coming from the extruder along x-axis. Then it will go like this. Then after that again, it will actually flow. So one time 90 degrees, then it will make actually second time 90 degrees. So x-axis, y-axis, again it will x-axis. So that will be that means the two x-axis, there will be distance between them. That distance between the two axes, the initial x-axis and the final x-axis, that one is actually called that distance, that vertical distance or the distance, whatever along y-axis, that is called actually offset. So because of actually this is a geometrical term we are used to use actually in other situations also. So because of that distance, that is called actually offset, the terminology offset, and based on actually that one, the type of die is actually are classified as a offset die. So according to the direction of flow of a melt, there are 3 types. One is inline die, second one is cross-head die, and the third one is offset die. Now we'll go for third types. Third one is according to the type of construction of die, how you are making the die. Because we all know the die will be manufactured from some metallic part and generally it is steel. So whether actually the total piece of that die will be a single piece of steel material or it will be actually that means different pieces, but you have to connect them actually by the help of nut bolt finally, how you are making it. So if you are making a single piece, your total die will be a single piece. Then that one is called actually integer dies. And to explain these integer die, split die and plate die, maybe I'll use the terminology of actually in case of a die, what is to happen? No, there are two sections. In any die, in any type of die, there are two sections. One is approach section, the other one is land section. Every die, whatever the product you are making, in all die, you have to make a die. And in all type of dies, whether it is coming under whatever category, everywhere actually there are two things are there. Two things are common. Their look and other thing will vary based on product, but one is actually at the entrance, that is called actually approach section. The approach section generally what is to do, it will receive the material from the extruder. Then after that actually it will be a divergent type of things, and after that actually it will go to the land section. Then after flowing through the land section, finally at the exit of your land section, what will happen? The product will come out. Plastic product will come out, and then after that you will go for cooling. So I am repeating for one thing, any die, they will have actually two sections. One is called actually approach section, and the second one is called land section. So an integer die consists of a single piece of die head. As I told you, actually all dies are made from actually steel material. That means the whole thing, total die, that is a single piece only. And want to change it, meant actually suppose you are using a die, you are using integer type of die. And after 1, 2, 3 years, actually, it is necessary to change it because of usage. After 2, 3 years usage, some problem you are getting, and now the thing is actually you have to change the die. Then on that case, you cannot change. It is not possible to change actually any portion of the things. That means on that case, you have to change the whole thing, because that whole die will be consisting with actually a single piece of metal. And that one is called, that means that land section as well as your approach section, land section, both together, they are not separate pieces. They'll form actually single one. And many times people used to make this one by actually casting process as a single piece. So an integer die consists of a single piece of die head. It has a tapered approach section and followed by a land section. This type of dies are used for plastic products with very simple cross-sectional area, like suppose you want to make a plastic rod, then there is no need of actually complicated geometry, because the part don't have any type of complicated geometry. So in that case, for your die also, there is no need of going for actually any type of complication. So better go for actually integer die. So the cost will be less. That is the purpose of going for integer die for a simple cross-sectional areas. But many parts, many other things, for example, PVC pipe and all actually cannot do with integer type of dies. There are some issues. As I told, actually one of the problem is, if anything gone wrong actually, then the entire die has to be changed. So it will be a costly matter. The other one is actually a split die. A split die is a combination of many pieces. It will be also consist of metallic parts, but it is not a single piece. For example, it will be actually the approach section, that will be a separate. Then the land section, that will be separate. Both you have to bring together. Then on the circumference, actually, you have to create actually the location to make actually the knot bolt type of connection. Then actually this here actually you need assembly. You need assembly of different parts to make actually the die. It is like actually, if I can compare our what we studied, no, these 2-plate mold, 3-plate mold, because these 2-plate, 3-plate molds, they are not a single piece of steel material. It consists with so many steel plates together, and they will form the mold. In the similar way, here in case of split dies, you can split it. The name itself is indicating actually, like in case of integer type, you cannot dismantle, but here actually you can dismantle again, make together. The third one is plate dies. Plate dies are very similar to actually split dies. But in case of split dies, what they used to do actually, suppose for example, land section will be a single section, approach section is a single section, they will make together. But in case of plate dies, what will happen? Even your approach section, what I'm telling actually in case of a split die, actually single piece. Here actually that plate, in case of plate die, the approach section itself actually will consist with so many plates, and you assemble all those plates, they will create the uh, approach section. Similarly, that land section, the length of the land section generally actually more compared to your approach section. The entire land section, in place of making actually single one, you can make it actually a combination of actually so many plates, one after another. You have to connect them by the help of knot bolt or by any other method of connecting. And finally, actually, they will create your land section. So the land section itself will consist with actually so many parts, so many plates, so many steel plates, and the approach section will also be consisting with so many plates. So here, if you will see the entire die, the total die will consist with actually so many plates, and finally actually you are assembling together them and making the die. So finally we can summarize the classification of dies. What I started from beginning, like actually